I'm Sebastian. I work for Immmr, which is a spin-off from Deutsche Telekom. And I'm responsible there for the engineering department and would like to talk a bit about what Immmr is, what it means to be a hybrid operator, and what technologies we use. And in the end, I have a bit of a history with TED, formerly working for Slovak Telecom, trying to create partnerships and actually also think a bit of what we already do with TED partners and to share some basically lessons learned with you. So if you think about doing something like that or want to get some of the things that didn't work as planned or that were a bit complicated for us to know about it, I'm inviting you in the end to have a short discussion on that one. So basically Immmr, and it's correctly spelled, I've been asked yesterday various times, so it is with 3M and no E. Immmr is an open communication service that is available for users, so presented to users on as Android and iOS applications as well as in web browsers. But it's not just an app or not just a messenger, it's actually a full communication service with much more to it than just messaging. And it basically, we understand ourselves of being at the intersection between classical mobile network operators on one hand, such as T-Mobile, such as Orange, so it's, these are like MNOs, and on the other hand, internet communication service providers that are purely, let's say, applications without any network running off of existing infrastructure. So we see ourselves being right in the middle. And one of the core messages of what Immmr delivers is basically boost for your phone, meaning that upgrading telephony in a way that in the past you were able to receive phone calls only on the one phone where you had your SIM card in and nowhere else. And with Immmr, actually, we are extending the reachability on one hand to any mobile phone where you're connected with mobile data, meaning you just need an IP connectivity and can receive phone calls there, make phone calls there, send SMS, and in the future also receive SMS, as well as Wi-Fi on any mobile phone or tablet or browser supporting WebRTC, right? Additionally, it also works with the classic GSM network, and I've asked yesterday Nir what he means by GSM. So I really mean the legacy network, the circuit switch network, not the packet switch network, but the circuit switch network. So it basically allows you to connect through various connections and have telephony available on all these devices, using not, let's say, technologies that operators usually would use. Dean mentioned it this morning, voice or Wi-Fi or VoLTE, but really just IP data connectivity. It also works when your phone is off. So currently, if I take your phone, or if your phone is off, runs out of battery, you actually either need to put your SIM card in another phone or you're just not reachable anymore. With Immmr, even if your phone is not connected at all, you're actually still able to use it on other devices or on a mobile browser. So it's not a client-based technology that you kind of distribute the call where your phone is acting as a kind of server or base station distributing content via the network connection. It's really integrated in the network, and the functionality that we provide is independent of the status of your phone. That's also very important. And it allows you basically to make phone calls wherever you are, as if you were in the country where your operator is registered, meaning if I'm now in Lisbon and I would have to pay high roaming fees, I simply connect to my Wi-Fi, to the Wi-Fi connection of the hotel, or to buy a local SIM card, put it in, and use the data connection, and I'm actually still reachable over Wi-Fi or mobile data with my original phone number. So I don't need to distribute people various phone numbers. It's enough to know the one that I've always owned for the last 10 years. For example, for me, my Slovak number. When I moved there, I bought a phone, I got a number, and this number is still usable with Immmr in all these scenarios. It also works when you don't have a good mobile phone coverage in your place or down here in the basement. It's actually okay here, but generally if you're somewhere where the mobile phone coverage is bad, we're extending it with Wi-Fi, and very importantly, it also works vice versa, meaning if you're somewhere where you only have GSM, you also be able to be reached, let's say, in-app. So imagine you're somewhere where you just have a GSM connection, no data, no mobile data, no Wi-Fi. You couldn't be reachable with Skype or with Viber, and with WhatsApp. With Immmr, you're actually still reachable for in-app calls. So it's very important to mention, I think. I said in the beginning we are an open communication service. What does that mean? Well, on one hand, I've explained you now that we are reachable via generally the phone network with your phone number, but you're also actually able to be reached via something we call Open Immmr, meaning it's simply a URL with your phone number, or in the future also some vanity name that you can choose, where anyone that you share this link with, so imagine you print this on your business card, immr.com/mark or something like that, people would go there and are able to connect with you directly in the service using voice over IP, audio, video messaging, and you don't need to log in, register, or download. If you like it, of course, you can download, but you don't need to use the service. We also support group video calling and messaging, so you can have a call with various people. On the mobile phone, I think due to the size, 4 people is what we usually do and what actually works quite well, but you can also choose more if you have a bigger screen available. Multi-party messaging is supported, as I mentioned, and besides the main phone number, that is the one that you've always had, we also support more phone numbers, multiple numbers that basically can be set up virtually inside the app, meaning if you use your one number for your personal, let's say, life, and you now start a business and want to have another number, you just buy a new work number. If you want to date somebody and not give your main number, you can get another number. So there are various use cases where multiple numbers are kind of aspired, and there is no need to get a separate SIM card for all of that, or a new phone, or a new contract. It's just at the click of a button or at the tap of a screen, and then you can use these numbers, assign a color, assign a name, and assign the number as well to contact. So if I have a work number or a TED Summit number, I assign it to Patrice. When I call him next time, I would use this number right away. So that's as well one of our features. And as I said in the beginning, we are supporting basically, we are a hybrid operator, meaning we have some offering of the app that I just presented offered to everyone. So that's the main features. The open Immmr audio, video, messaging, group communication, multi-device is offered to everyone. And some of the things are offered exclusively to telecom customers, mostly because they require a network in the background. And that's basically what we are going to start with in Slovakia. So the company I've worked before I started with Immmr, so when I was here last year working for Slovak Telecom, I was already working on integrating Immmr there. And this is the first country where we're going to go live with these features, such as calls and SMS, multiple numbers outgoing calls, and also the actual virtualization of the number. I'll demo this right at the end. I don't know if there are questions. We can maybe do it in the end, right? So I'll move on with the technological part, bridging a gap, let's say, unconventionally and with the latest technical approaches. What do I mean by that? Well, I already said we are not using technology such as voice or Wi-Fi or Volta or even IMS in the background. So we are not just attaching some WebRTC front end or the application to a carrier network. We actually use our own backend and front end components that make this whole solution and the service architecture much leaner than you would do that if you would just extend and operate a network. So I'll just go through a few of the technologies we're using without going into too much detail. So as I said, we have an Android, iOS, and web application. We're using CouchDB for replicating the databases between all of these devices. When you add a new number in one of the devices, it will appear on the other one. For contact recognition, this is also something where we are using CouchDB in the front end as well as on the back end. Our architecture is based mostly on microservices, which means we have small services that we can put in a container with their own database, and they communicate with each other using a message bus. And we have, as I said, CouchDB already for contact recognition. We also have a persistence layer using Postgres in the background for all data that we need to, let's say, store more permanently. This Postgres is not yet put in a container. It's basically in a separate instance, but all the microservices are in a container. We can deploy them as we want. You'll hear about more of that in a minute. That's the back end, let's say, for the more for the services part regarding the communications. We are using a backend from Genband called Candy.io. The Candy guys are here this year. They were here also last year presenting. So that's the main communications backend we're using. We're using WebRTC in the browser as well as in the applications in the SDK, let's say, that comes with Candy. We're using SIP for outbound calling and for integrating with both the NATCOs as well as with our termination provider, and we're also using IN to integrate with the carrier networks. I have an overview in the end, like of the whole architecture. I just didn't want to dive deeply into an architecture diagram, so just a few words about the things we're using. Regarding tooling, it's quite a modern, I would say, tool chain. So we're doing continuous integration with Jenkins. All our configuration, config maps, and so on is in Chef. So We are a quite distributed team, so to organize the work, basically, we are using Git for the code and for the configurations, have all of that in Chef. Using Kibana for storing the logs from all the microservices in a central place. Redis is used for caching, and Selenium, I've mentioned that already yesterday, is used for browser testing, for example. So you can automate browser scenarios using Selenium, kind of log in, open your browser, start a call, receive the call on another browser, and then see if the connection worked well. And you can automate testing, but also monitoring, end-to-end monitoring, right? Regarding hosting, we are hosting Immmr on AWS in Frankfurt, but of course theoretically it could run on any location, but we are doing it in Frankfurt. We are using Kubernetes for the container management and for kind of the cloud management, and we also have a few virtual machines for when a container is not really feasible. I'll skip the detailed Kubernetes slide. Basically, what this slide shows you, and it's also not fully adjusted with the sharpness. So basically, it shows we have containers. We're using AWS services, and I'll skip that one. Regarding the telco integration, maybe an interesting part. Some of you here have a background in telecom, so we're using IN triggers, mobile originated, mobile terminated, that we are connecting to the Immmr platform to actually be in charge of the call. SIP trunks I mentioned already, and we also integrated with the NATCOs, with the telecom companies in all the all the countries where telecom has a footprint, with the provisioning system, so that you can buy a local tariff and then you can get actually Immmr on top, as well as billing. So Immmr is also not having necessarily a separate billing infrastructure or billing experience. Once you have the application on top of your normal tariff, you're billed right within that tariff. So you can bypass this if you're not with a telecom, or if you feel like you need an additional country pass on top of your normal tariff, you can buy that from us. But we are also integrated directly with the NATCO. And there's a very, very high-level drawing, just that you understand a bit how it works. So you have the end devices here. They are connected to both Candy as the main communications backend, as well as to the Immmr infrastructure for your profile, for billing, charging, your multi-number management, and so on. Immmr, in turn, is integrated with a third-party billing operator, but also with Candy. So, of course, our main backend, consisting of the Immmr parts itself and of Candy, needs to communicate. And on the Candy side, we actually have use Nexmo for SMS, Voxbone for the multi-numbering, and both infrastructures are also integrated with the telecom part. And if we look a bit, to conclude slowly, more detail in the telecom part, as I mentioned, we can see that with the OSS, BSS, we're integrated for provisioning and for billing and charging. With the STP and the HLR, basically, we are connected for call control. For actually, because we are not just using virtual numbers, but your existing numbers that is owned by the telecom, we have to make sure we are kind of in charge of that communication path. And this goes to the backend we've worked on, and for outbound calls for customers of the operator that we're integrating with. Of course, this goes directly to their media gateways. Wrapping up, I was saying and I already mentioned most of them, how the TED ecosystem can help. Well, actually, we are already partnering with many companies that are here. So you see some of them here, Dialogic for group video, Voxbone for DIDs, Nexmo for SMS, and Candy as a main provider, but there is also space. So I've been in touch with quite a few companies here, and we discussed how we can kind of work together and keep the discussion going. So I think there's a lot of space for other use cases, for new use cases where we have interesting solution providers or other operators actually that are experienced with this. And last but not least, some lessons learned. As I was mentioning, we're hosting on AWS. I think this was the most important, the hardest part to actually get a compliant AWS hosting done in Europe, because it's an American company, and we are basically both have to adhere to the German laws as well as to the European data protection laws. So that was one of the efforts that we had to take to actually be able to host there, and we've made it. So we are compliant there. Sometimes what we realized in building all of that and developing it is that there's sometimes a bit of a misalignment between the Scrum methods and Kanban methods, so agile methods inside Immmr, and the waterfall planning on the other side of the telecoms, and also talking towards basically stakeholders. We have we've seen that sometimes, if they expect to give expect you to give them a date, and then development is just not, as far due to various reasons, then it's always kind of hard and needs to be basically adapted, and that's why I basically planned also to be here longer and to have launched already and show you a launch service, but we are not there yet. We are very, very shortly before that. The iceberg effect is also part of the telco heritage. So for many people that see the app, it really is just an app. That's why I was emphasizing at the beginning, we are not just an app. It's like, the small thing that you see is the app, but the big monster of technology is actually under the water, and I've kind of given you a glimpse of that in the previous slides. Development-wise, we are using still OpenStack for development, and for QA and production we use containers. So what we learned is that we should also get the development basically moved to container architecture, because there are differences in that, and although it's maybe a bit easier for the developers, some of the problems you just face later, and it would be better if you would face them earlier. And last but not least, I put there with SMS, since we are a service sending SMS, but on behalf of users, we've run into various issues with person-to-person versus application-to-person SMS. So that's, the last thing I think that I've put here. I've planned a short demo. I think I don't have time. Mark is already standing here. Really quickly. Okay, so yeah. So basically, if just want to show you that it basically works when I have a phone here, a normal phone. I use the normal dialer, and I call my number. I just want to show you that it basically rings in the browser, and when I log out, it rings on my phone. So I hope it works. So you see, this is like the native dialer of one iPhone. This is my other one, right? And ideally, if everything goes well, you see here I have an incoming call. So the browser is ringing. We are connected. And it's basically working, so it rings inside the browser. The call is ended. If I log out now, the service automatically realizes that no IP device is connected and tries to send the call then to my normal phone. It's kind of a fallback, right? It would work the other way around as well. So if I'm, you can now imagine I'm basically not within reach, and if I'm lucky and the demo works, then okay, it says please try it again later. So that part didn't work, but the first part worked. So that's the most important part, right? Great. So thanks everyone for your attention, and yeah.
We probably have time for one question while Trees gets set up. If anyone has a question?
Yeah, I mean. No, normally it would just hear ringing. So now there was an announcement because I'm probably not. I probably don't have service down here with my normal phone. But basically, you would just hear ringing. So for the calling party, it's very transparent. So you either hear ringing and the browser rings, or you hear ringing and the native phone rings. But there is no distinction basically, and also no decision, right? So you just call the number, and the call is being established the best way basically possible. Yeah. Okay. Thank you.